I'm audible, right?
Yes,
Yes.
you're on.
Okay. Just give me a second. Okay. So let's start with this problem. My screen is visible, right?
Yes.
Okay. So this is the first problem, and in this problem, we are given that we have an array A of length n. So it contains integers, and there are two initially empty arrays B and C, and we'll add each element of array A to exactly one of the arrays B or C. So we have two conditions that need to be satisfied. So the first condition is both arrays B and C are non-empty, and second is for any two indices I and j, I belonging to the array B and j belonging to array C, Cj shouldn't be divisible by Cj shouldn't be a divisor of Bi. So Bi shouldn't be divisible by Cj. So I think the problem statement should be clear to everyone, right? Is there any doubt in the problem regarding the problem statements? Is there someone who couldn't understand the problem statement? Okay. So basically, see, we just have to divide these elements into two. So what we can do, see, there are many ways to solve this problem, but one of the ways is, let me, so one of the ways to solve this problem is, see, I have an array A, right? I have an array A, there are some elements, and I try to see some elements should belong to array B, and some elements should belong to array C. So first of all, it is given like one of these conditions that needs to be satisfied is Cj shouldn't be a divisor. Cj shouldn't be a divisor of Bi, right? This thing. So this thing shouldn't be true, right? Yes, no, anything?
Yes, sir.
Okay. So what will we do? See, first of all, just sort this array A and just try to come to an index for which this value is not equals to this value for the first time. And what you can do, you can give all of these elements to your array B and all the rest of the elements to your array C. Why? Because see, at this point, since you have already sorted your array A and these two values are not same, this means that, let's say this is index I and this is index I plus 1. This simply means the value at index I plus 1 is more than the value at index I. So all of these values are definitely more than these values. So if x modulo y is always equals to x when y is more than x, right? So this isn't dividing, like these, any of these values won't divide any of the values that I have in this part. So is this clear?
Yes.
Yes, it's
Okay, what about others? Just write yes, no in the chat. Okay, someone asked me to repeat. See, first, we just have to divide these elements into two arrays such that all the elements in the Bi shouldn't be divisible by any of the elements in your array C. So what we can do, first of all, sort our array A and then pick an index for which the value at index I is not equals to the next position, that is the next index, that is I plus 1. So this simply means that all the values that are in this part are more than all the values that are in this part. So you can give all of these values to your array C and all of these values to array B, right? It's clear. Is it clear now? Okay. So I'll show you the implementation. So this is the implementation, and in this, I'm first taking n as input, then I'm taking array A as input. So after sorting this f is just a flag to let me know that I have already found the answer and I don't have to print -1. So what I'm doing after sorting this, if the value at index I is not equals to the value at index I plus 1, I'll simply print the number of like terms that are in the first array and in the second array. So these are those I plus 1 in the first and n minus I minus 1 in the second. So I'm going to print the first I plus 1 elements for array B and all the rest for array C. So this is clear, right? Okay, so let's go to the second problem. So this is the second problem. In this, we are given that, okay, somebody has written a big logic. Okay, like it's okay if like there are many ways to solve that first problem. If it worked, okay, so it didn't work. Okay, so what will we do after this session has ended? I'll come to the queries that I couldn't answer during the like during the session. Okay, and in case if at that point also your doubt isn't resolved, what you can do, you can just raise a query and ping me in it. Okay, so right now, so that the flow doesn't break. Okay, so coming to the second problem, in this problem we are given that the rtem suggested again to girl Olia, and there are n arrays where the ith array contains mi more than two positive integers. So there are basically two or more positive integers in each array. Now Olia can move at most one, possibly zero integers from each array to another array. Now it's possible, like it's only like we can only remove one array from each element, but it's possible that like we move multiple times to one array. Then the beauty of the list of the arrays is defined as, you'll for each array you'll pick up the lowest value and you'll add it to your beauty. So our final goal is to maximize the list, like maximize the beauty of the list of arrays after doing these operations. So let me just quickly show you. See, we are given n arrays, and what we can do, we can pick, like for each array we can pick one of the values and we can move it to the second. From this also we can pick one value and move it to some next, maybe this. We cannot make sure that you're not doing this thing. From this you'll move it here and then again you'll move, because these all are happening simultaneously, first of all, and secondly, you cannot, like what is the point of moving this value from here to here and then to this vector? You can just move this directly here, right? So coming back to this, now we'll move our values like this, and finally what we have to do, we'll have to move, like we'll have to find the beauty. So what is the beauty? See, after you have done all of these transitions, for each array you'll pick the minimum value, and like for all of these you'll pick the minimum value and you're going to add that value. You'll take sum of all of these values. So first of all, is the problem statement clear? This is the beauty and we have to maximize this. Is the problem statement clear to everyone? Okay, perfect. So now see, first of all, tell me, see, if there is a value which is least in all of these, there is a value like every other value is maybe in order of 100 and there is a value 1. So will this, can you always say that this 1 will always come to your beauty? Like the final, this will always contribute to your beauty value? Yes, no. Is anyone having any doubt that why this 1 will always come? This is, I'm saying this is not least of one array. This is the least of all the values. Like for all of these n arrays, this 1 is the least among them. So basically, if you also move this 1 to any other array, finally, this will be the minimum of that array. So this will always get added to the beauty. But what about others? See, what we can do, we can pick other minimums for all the other arrays, and we'll try to make these minimums come to this array in which the minimum of minimums is there. like in which the least value is there, we'll try to take all of these minimums and we'll try to give that array these minimums. And then what our answer is going to be, for all the arrays except this array, we are going to pick up the second minimum for all the arrays, that is for n-1 arrays, and we are going to take the least value also for all the arrays. So this is our answer.
Should we not send all the minimum to that array which has the least second minimum?
So how will it, like if you do that, that particular array will have now this as the least value, right?
Yeah.
You can do, so you, in a way, you're doing that thing only, right? So you'll have this one plus this second minimum for n-1 arrays. So now you just have to find a way that these n-1 second minimum values should be as max as possible, right? So yeah, that's a way of doing it. So just give these, like for these n-1 second minimum, like suppose you have n arrays and this is the array that has the least second minimum. So it's beneficial to take your minimums, like second minimums from these array, because this value is not going to change, right? But you can increase this value. So how you're going to increase this value? You can pick those, like the other arrays, and not pick this array which has the least second minimum. So actually we are not sending any element to anywhere, but we just have to pick like those n-1 second minimum values and the least value among all the n
Sir,
array.
sir, the minimum point is clear. But the second minimum, please explain again.
See, there is a least value that will always come, right, to the beauty, right? Yes, no, anything?
Yes.
Okay. You can keep yourself unmuted, like while we are discussing. So let's say there's a minimum value that is always coming. Now, for one vector or for one array, I'm always going to get this least value. So let's say my least value, I have decided that it's going to be in this vector or array. So now there are these n-1 arrays, and let's say I have sorted these arrays, and these are those arrays after sorting. So if I give this value to this array, what will be the like minimum value left? This will be the minimum value, that is second minimum, right? Second.
Right.
So it is better to take, instead of minimum, since I want my beauty to be maximum, it's better to take this second minimum for all of these array instead of this minimum. So how to do this? You just give this minimum value to your vector which is having the least value, and which should have the least value, which has the least, in a way, like you can say, like don't get confused by these terms. So in a way, the least value should be in the vector or in array which has the least second minimum. Why? Because for all the others, you'll get, see, you're going to get n-1 second minimums out of n arrays. You're going to get n-1 second minimums, and plus you're going to get the least value always. So you don't have any control over this, but you have control over this. So which n-1 second minimums will you pick up? You'll pick up those which are the maximum n-1 second minimums. So you'll leave the least second minimum, right?
Right,
Is
sir.
it
Okay, sir. Sir, one thing more I would like to ask is that what about the constraint which is there in the question that you can only move one? Like in the contest
I'm
also,
moving only one element, right? I'll move my this least value to an array which has the least second minimum. And for that least second minimum, the minimum is going to be this least, and it will have all of these minimums. So automatically for all of the rest, I'll get this
oh,
second minimum as the minimum value. And for this array, I'll get this least. Is it okay?
okay.
Okay, I'll
Sir?
pick up an example quickly. Yes.
Yes, so basically you are trying to saying that it's basically same with if I take sum of all the second minimum of the arrays and
Yes.
then subtract, and then I subtract it from the minimum of all minimum, I mean second minimum of the array, then I add it with the minimum of all minimum of arrays.
Yes. This should work.
So is it same? Because I
Yes.
did the very same in the approach, and in the fourth test case it gives me wrong. I have sent the approach in the comment section. It's in one line actually, not code. the approach I have sent?
Like I'm pretty sure that this should work because like you did very much same thing, but I did exactly same, so it worked. But okay, let me check. Can you just write it again in the chat?
Yes, sure. Okay, I'm sending you again.
Yes,
So
yes,
this one.
okay,
Yeah.
answer is equals to sum of all second minimums of the array plus minimum of all the minimums of array minus minimum of all. So then there is some, like you did some computational mistakes.
Hello, Ankit.
Yes.
Yeah. So I had it out, like if we add all the second minimum values in an array and sort that, will the sorting give us TLE or it will?
Like you won't get TLE.
Okay.
Okay, so let me take an example because many people are asking for an example. So let me take this third example. So we have 3, and the first array is 100, 707, and 5, right? So let me write this in sorted order. So we have 5, 7, we have 5, 7, 101, 1001, and 1007. Just keep confirming that I'm writing the right values. If I mess up something, just let me know. 8 and 11, 6, 8 and 11. And then there's 2 and 9. So see, first of all, these are the arrays in sorted order. So what is the minimum most value? It's 2. So what is the sum of, like, what is the second minimum? What is the minimum second minimum for all of these arrays? 7, 8, and 9. It's 7, right? And now add all the other second minimums. So you'll get 8 plus 9. That is, what is 8 plus 9?
7.
Plus 2. So this is 13. Just give me a minute.
17, 8 plus 9.
What? 8 plus 9. Okay, I'm sorry. This is 17 plus 2. This is 19. It's okay, right? Is it okay? Like, if you'll remember, in past also I have done these kinds of mistakes, right? If somebody has been like in the previous batch also, you would be familiar, like I do these kinds of silly mistakes. But anyway, is it okay for everyone? Like, I don't know how I wrote 8 and 9 is equals to 11. So is it okay for everyone?
Yes, sir. Understood the approach. Sir, just one query after the session. Could I show you my code and can you debug it? I mean,
Yeah.
with this very
Just,
same approach.
Yes. Raise a query. Like, I think it would be a minor error, but just
In
raise
this
a
session,
query.
after the recording completed.
Yeah,
In this
like just raise a query. I'll stop the recording, and in that query, you can share the code. So I'll look the code. Look at
Okay.
it.
Thank you.
Once again,
Okay. So should I move to the implementation?
Yes, sir.
Hello. One second.
Yes.
Can we do in a n square also? Because I have done in n square and got accepted.
Okay. I'll ask everyone like who is having particular doubts that are not common for everyone. Just wait for the session to end, and I'll answer all of these. I don't think this can be
Hello?
answered. Yes. Okay.
Yeah, so
I
can you
don't think
can you
N square
go
will
over
work. N square will give you TLE. Yes. So what is the doubt?
so the excluding the second the minimum second value,
Yes.
what is the logic for that? Like if we move all the second
See,
minimum
basically,
values
for
to the
each, you'll get always the least value. That is this 2, right? No way. Like there is no way that you can skip this value, right?
yeah, that I got.
Okay. So now for one array, this is fixed. And for other arrays, you'll try to pick up, for n-1 arrays, you'll try to pick up the best value that you can pick up. So either you'll get the minimum value or you can pick up the second minimum. Why second minimum? Because you'll try to make their minimum shift to an array which has this 2. So simply you'll try to keep the minimum and like the minimum of all of the arrays in that array which has the lowest second minimum value. Because for all the other arrays, you'll get the second minimum added to the beauty. Is it okay?
Oh, okay, I got it. So you're pushing everything to the array which has second minimum because from that array you will get the minimum value, which is
Yes,
2.
and for all the
but
other n
all the
-1
other arrays will contribute the
second minimum.
top n-1 maximum second values.
Yes, yes,
Okay.
yes, exactly.
Okay, got it.
So let me show you the implementation. Okay, so this is the implementation. In this, I'm first. Okay, this is not the implementation. Okay, this is. Yeah, this is the implementation. I'm first taking n as input. Then I'm taking, these are two vectors, a and b. A will finally have all the second minimum values. Okay, and so, and this min will have the lowest minimum value among for all these arrays, like minimum for all of the values that I have in n arrays. So I'm taking n arrays as input. So the size of the ith array is k. So I'm resizing my b, and then I'm taking b as input. Then I'll sort my b, and I'll update my minimum, minimum, that is the lowest value for all of these arrays. I'll update that, and I'll push this second minimum in my a. Then finally I'll like sort my array a, and instead of like now a of 0 will give me the lowest second minimum for all of the arrays. So I'll update that value with minimum, and finally I can print the sum of array a. Is it okay?
Yes.
Okay, so let's go to the third problem. Okay, somebody has like, okay, try avoiding like sending your complete logic in the chat, because then the chat becomes like very big, and it's possible that I may skip some of the genuine questions. If you want to share your code among yourselves, like try sharing it directly. Write a direct message instead of like sharing it in the chat with everyone. Okay. Okay, I don't know where I am right now. Okay, so is anyone having any doubt regarding this problem?
Sir, after sorting, what is the like meaning of that line, next line? Min.
Okay, mmmin. So let me. You're talking about this thing. So
Yes, sir.
mmmin,
Okay.
like I said, we'll have to get the minimum value for all of the, like, which is the minimum value among all the values, like for
Okay.
the of the NRS. So that is the mmmin. That is the least possible value, like the least value that is present in all of the NRS.
And this accumulate,
Accumulate is okay. You are from which level?
I'm from level like 2 only.
Like I taught this. Okay, accumulate is a STL function, and this basically is taking the sum of all the values.
Okay.
Okay, yeah, I actually took a class for STL. Like I think it was last week. So yeah, you can watch a recording. It is like I've explained all the STL functions in that.
Okay, sir.
STL one. So if this is okay with for everyone, we'll move ahead. Okay, so waiting for the third problem. Okay, we'll go to the third problem. Okay, where is it? So this is the third problem, and in this problem, we are given that Andre is just starting to come up with problems, and it's difficult for him. So that's why he came up with a strange problem about permutations. So initially, you are given a permutation, like you're not given a permutation, but you know what a permutation is, right? So I'm
Yeah.
thinking, yes. So then the cost of a permutation P of length L of length N is value of this expression. So sum of, let's say, okay, I'll show you it here. So basically, if I have a permutation like this, yes, is anyone saying something? Okay, so let's say this is a permutation of length 5. So I have maybe 5, 3, 1, 2, 4. So the cost of this permutation is going to be 5 times the index at which 5 is. So 1 plus 3 times the index at which 3 is 2 plus 1 times 3 plus 2 times 4 plus 4 times 5. Then you have to subtract the maximum of these values, the maximum of pi into I. So this is 5, this is 6, this is 3, this is 8, this is 20. So I'll have to subtract 20. So this is the final cost, and this is the value. So we have to now the problem statement asks us that we have to output a single integer that is the maximum cost among all permutations of length n. So is the problem statement clear to everyone? Like this cost is for just this permutation, right? I can write a permutation of length 5 like this also, 5, 1, 3, 2, 4. So this is also a permutation. So out of all of the n factorial permutations, there are total n factorial permutations for a length n. So out of all of these permutations, you have to find the maximum cost. Okay, so now how to do this?
Is it a pure maths problem?
Yes, I think so.
Yes.
Okay, so now coming back to this problem, we have some values, and see, n will be less than or equals to 250 for a single test case, and the total value of n will be always less than or equals to 500. This is given in the problem statement, the constraints. So see, first of all, if I tell you, see, what is the maximum values that you can get? Maximum value will be somewhere between 1 to n square, right?
Yes.
I'm not talking about the maximum value of cost. I'm talking about the maximum value of p, this particular thing, that is pi into I. What is the maximum value that you can have for pi into I? It's between 1 to n square. Like actually it's 1 only in case of when the array is or the permutation is of size 1. But in general, this will lie in between 1 and n square, right? If you make some permutation, like if you make a permutation of length n, the maximum value that you'll get for pi into I will be between this range. So now,
Isn't it n to n square?
what?
He is saying that n to n square.
Yeah, like don't worry about this lower part, this lower range, okay? I'm not worried about this. I'm just worried about this upper limit. So it will be less than, okay, let me write like this. It will be less than n square, right? So what I can do, I'll first try to maybe, okay, let's say you are given an x and you are saying that every value like pi into I will be less than x. You're not trying to be you will try to make a permutation which has for each of these values, the value is less than or equals to x. So what should be the order? Like if you have to satisfy this condition and you have 1, 2, 3, these are the positions. Maybe let's say the n is equals to 7. So what should be multiplied? Like what should be the index of 7? Let's say these are the numbers 1, 2, 3, and these are the indices. Like these are the positions. So this is the first index, second index, third index, fourth index, fifth index, sixth index, and seventh index. And let's say x is equals to 20. So the maximum value that a pi into I should be less than or equals to 20. So what do you think this 7 should take? Like what is the position that this 7 should take?
If we will reverse and then multiply them.
2.
No. Is it all? Yes, it should be 2. Why? Because I'll try to give this 7 the maximum index for which the value, like after multiplying this 7 with that position, is less than or equals to 20. If this value.
Excuse me.
Yes.
Why we are taking the value 20 here in this case?
I'm just taking an example. Don't worry about this 20.
Binary search.
So basically, if there is a fixed value that the maximum should be less than or equals to 20, you know the positions of each of these values. Like you'll try to fix it, right? And if by any chance, like I don't think like you can get 20 here. Like even if you give 6, like 7 will come to this position, 6 will come to this, 4 will come to this, 5 will come to this, 2 will come to this, and okay, I skipped 3, so 3 will come to this, and 1 is left, so 1 will come to this. So basically, if x is equals to, like you are not like, what is the multiplication? Let me write the multiplication also quickly. So okay, I have 7 to the 14. So if you want to make a permutation which has the maximum value less than or equals to 20, this is the permutation which will give you the maximum cost. Why? Because I'm always multiplying my biggest element with the biggest index that it can be multiplied with. Basically, if there was
what is x?
what is x? X is basically the maximum value that pi into I can take.
Okay, okay.
So these are the products, like these are pi into i's. So
So here
basically,
we should take 49 in this case.
like 49 is more than 20, right? 49 is more than 20.
But
I'm saying these values should be less than
pi,
equals to.
but pi into I can be up to 49.
But I'm saying if it is up till only 20, then
Okay.
so in like I'm trying to like cap my maximum value that the array can be, and then I'm trying to make the permutation which will give me the maximum cost. In this case, you'll add all of these values and you'll subtract this 20 once. Why? Because 20 is the maximum value. So this is the cost. So now what we can do, for like I said, the maximum value can be between 1 to n square, or maybe less than n square. You can try for all of these values and you can see if this is your maximum value. You are saying that, okay, your maximum value will only be this thing. Let's say there is this thing x. So you can find, okay, find what is the cost. So keep doing this for all of these values, and the maximum cost that you get for all of these x's is your final answer. So first of all, is this thing clear to everyone? I'll come to time complexity, everything in a moment. You're just iterating our x from n squared to 1, like this way, and we are saying that x is the maximum value that can be there in our, the x is the maximum value that pi into I can take. So then I'll make a permutation, and from that permutation I'll get the cost, and if this cost is more than my current answer, I'll update my answer. So this thing is clear to everyone? Just write yes, no in the chat.
But for 1x, there may be many costs.
No. I just explained, right? So I just explained you for a single x. For a single x, there is only one way. Like if it's not 100% sure that you'll be able to make a permutation that has the value less than or equals to 20, because if I maybe let's say I reduce this to, so there is no possible way to make a permutation which has like a permutation of length 7 which has the maximum value pi into I only up till 2. So but if you this value is some, like if there is a possible way to find, then you'll get a only one permutation. Why? Because as I'm saying, you'll always try to multiply the maximum value that you have with the maximum index that it can be multiplied with. So like 7 will always be multiplied with 2, not 1. Why? Because it will give you less cost. And 7 won't be multiplied with 3. Why? Because it will give you value more than 20. Is it clear now?
ये 1 पे क्यों मैं cost कम आएगी?
Because you're doing 7 into 1. Now you're doing 7 into 2. Like what is the maximum value that you can multiply with 2? It is this 7 only, right? After it, maybe you multiplied 1 with 7 and 2 with 6. So this is definitely less than the arrangement that we have right now, because 7 was getting multiplied to 2. Right?
Excuse me, sir.
Yes.
Sir, like we will iterate from by taking like x equal to 49 to 1.
Yes,
right?
yes. In this case.
Okay.
So why are like what's the intention behind like taking
Yeah,
x
like I
from
said,
1
I
to
didn't get
49?
any intuition for this problem. Like I was trying for other approaches also, but this just like there is no intuition for this. Try for each and every x that if this is the maximum, what is the maximum cost? There is no algorithm and nothing. I'm not using binary search. I'm not using anything. There is just one catch, that the time complexity for this. Okay, who did this? They kindly remove this. Like it will be visible in the recording also. Okay, so there is only one catch. What is the time complexity for this? See, for all the x is n square, right? I'm iterating x over n square values. Then this value is getting multiplied by n, and see, I have to pick the indices also, right? So for 7, I have to pick the biggest index that is available right now. So for this, it will be log n. Why? You'll either use a set or something other similar to it, but I don't think anything, like I couldn't come up with anything that is better than set in this. So now, what is the time complexity of this? It is n cube into log n. So if you put n as 250, Can someone just quickly calculate what is the value for this? What is 250 cube into log? This is base 2. It is less than, I think it is less than 1e9. If you divide it by 1e9, you'll get something like 0.12 something. So, but still, like usually these kinds of operations can be done within like around in 1 second. Like 10 to the power 8 operations can be done in around 1 second, I think. But still, and like the time limit for this problem is 3 seconds. But still, I'm pretty confident that this will give you TLE. Why? Because see, like we read that the time complexity that is theoretical is different than the practical time complexity, right? Then
ये कहाँ दिया है?
what is given?
This practical less than theoretical.
You'll probably read this in. Are you from CS department? Like this is taught.
Yes, yes.
Like probably like yes. So sometimes like the solution that mine solution is having a time complexity of like theoretically it will be this only, but the things like you can break your loop if the value is not like see if you're checking for some x and it turns out to be that x into n is now less than like each element was even x and it is less than your answer that you have calculated till now, so there is no way, no need to check for all the values of x below this point, right?
Yes.
So I can simply break. There is one more thing that you can do. See, you don't have to go for all of these x values from 1 to n square. You only need to go to values that are actually possible. So what are the values possible? See, if you have 1 to n, if 1 is getting multiplied to everything, you have 1, 2, 3 till n. Then you have 2 multiplied with all of these values. You have 2, 4, 6 till 2n. Then 3 up till n. So this is 2n. This is 3n up till n square. So only check for these values. So if you do this for 250, 250 square is more than, far more than this thing. This will turn out to be 16,000 something, I think. And this value will be more. This will be, so I think it was around like 625 something.
62,500.
This thing. So this value. So like the theoretical time complexity is still the same, but like the number of operations that are being done now are far less. So that's why the solution will get passed. And I think there are better solutions, like the better approaches that have been shared in the chat. So there are some n square also. And someone is saying that their solution passed in n cube by 6. So basically the idea is either you do it in n square or you do, if you're doing going up till like n cube or something, you'll have to have a divisor here. Like you'll have to somehow reduce it.
But if we pair pi to I means 1 to 1, 2 to 2, then the summation will be maximum, but the maximum will not be maximum.
Yes. So in that case, I'm not saying you take x as your maximum. You are just saying that the every pi into I should be less than x, but finally you are going to pick the maximum from this permutation only, right? You don't have to pick x. Okay.
Okay.
So I'll show you the implementation. So this is the implementation. In this, I'm first taking n as input. Now this is my answer. This is the sum of the pi into i's for a permutation. This is the maximum of those pi into i's. This is just a flag. Then this is a set. This is just what all sums are possible. So you can check here what is the size of this possible for maybe 250. So these are just temporary variables. Now I'm sorting my possible from in decreasing order and I'm iterating over those. So first of all, I'm checking if this x into n, if every element in my, first of all, this is not possible, but still if every element in my permutation was equals to x only, that is the maximum that it can be right now. So if this is still less than answer, that is the value that I have calculated till now, I'll simply break this loop. Otherwise, my sum is 0, maximum is 0. I'll insert all of the, like these are the indices that are available to me. So I'll insert 1 to n in my set. Now I'll try to give each of the values the maximum index that they can be given. So from 1 n to 1, I'll check what is the, if the lower bound of x divided by I. So this is the position that I can give, plus 1 means that this is not that I can give. So I'm finding lower bound. And if this lower bound turns out to be the lowest value in the set, so this means the lowest value in the set itself I cannot give. So I'll mark my flag as 0 and I'll break this loop. Otherwise, if this loop is not broken, I'll come to this place, I'll pick that position. So basically st.lower bound was the lowest value that I cannot pick. So if I'm doing minus minus, it will give me the one previous value, right? I'll take this star is simply, this will give me the address and this will give me the value. I'll erase that index value from my set. Then I'm going to take my mmmax as maximum of mmmax, or this temp. This is the index and this is the value. So this is the pi and this is I. I'll add this to my sum. And finally, I'm checking that if in case my loop, this was broken in between, that is this way it's not possible, I'll simply continue. Otherwise, I'll take my answer to be maximum answer, comma, the sum, total sum of pi into i's minus mmmax. So is it clear?
I think.
Yeah, I'll share, like you'll get all the solutions. Yes, I'm going to discuss D also.
Hello.
Yes.
I want to ask, like, what is the prerequisite for these kind of problems, or is it like a normal C problem?
I think
or
like
is
this problem can
it
be
is
solved
not a
in
normal
like
C problem.
No. This problem can be solved very easily. Don't look at my solution and like sometimes we overthink, and I usually start overthinking after a point. So I think I have done, like I have over implemented this. Like the solution for this will be really easy if you look at the editorial. But the point is, you get this solution also, right? This isn't using any kind of observation or anything. I'm just applying brute force. I'm checking for all of the values.
Yeah, I got it, but I'm just asking like a general question. Like for C, like this is a C, and as we have seen
Like,
the
I think
solution, is it a
usually
normal
C's are
difficulty
more
C, or
harder.
is it a?
It is easier than usual.
It is on the easier side.
Yes.
Yeah, got it.
Now D.
Okay. So let's go to D. So this is okay. This is the D problem. In this problem, we are given that there is a capital of Tiagoland, that is Capigrad, and basically the Tiagoland is represented by a number line, and the city of Capigrad is located at point 0. So there are n portals all over Tiagoland, and each of which is characterized by 4 integers li, ri, ai, bi. So basically these li, ri simply means that if you are in between, like if you are at anywhere in li to ri, you can simply go to anywhere between ai to bi. So this way we are given n portals, and okay, the post contest recording you will get after 2-3 hours once it gets uploaded on YouTube. So we are given n of these segments, and initially, like we are given q queries, and for each of these q queries, we assume that the Andre is initially at x1, maybe at xi, and from that position, Andre needs to go to as far as possible from this 0th position, because at 0, this is the capital, which is located at 0 index. So first of all, is the problem statement clear to everyone?
Yes.
Okay, not clear. Okay, what about others?
No.
Okay. So
No, sir.
okay. See. See, we have a number line, and for each of the, and this is the 0, and there are some segments given to us like li, ri, ai, and bi. And for the ith segment, it's 100% sure that li is less than ai, less than or equals to, then I think it is less than, yep, then this value is less than or equals to bi, and then this value is equals to ri. Basically, ai to bi will always be somewhere in between this range, li to ri. So now the problem statement says that if you are at any index between li to ri, if you are at any positions between li to ri, you can transport or teleport from this position to any positions between ai to bi. if you are here, you can go here. If you are here, you can go to here. So this way, Andre will keep doing these operations and he want to get as far as possible from this zeroth location. And you're given Q queries, and in each query you are given some xi, like this is the positions from which Andre is starting, this is the position from which Andre is starting. So what is the farthest position to which Andre can go by these operations? So is it clear now?
Initially, Andre is at which position?
What? I couldn't get you.
Initially, he is at which position?
X, like you are given for each query. It is different for each query. For each query, you are given this X. This is the initial. Like for ith query, you'll have to take Xi as the initial position at which Andre is there. And then from that position, you'll have to find what is the farthest point to which Andre can go. Is it clear now?
Okay.
Okay. So is the problem statement clear to everyone? Just write a yes, no, anything. What Andre wants, I also don't know. Like he just wants to go as far as possible from this zeroth location, zeroth index location or zero position. He wants to go as far as possible towards right from this zeroth place. And for each query, you are given some xi, that is, assume that Andre starts from this location. So what is the maximum position to which Andre can go? Is it clear now? So I'll come to the solution, that is the movement part, in a moment. But first of all, I just want to make sure that the problem statement is clear to everyone. He can only jump where there is a line. So basically, no, he cannot only jump where there is a line. He can start a jump from only this Li to Ri if he's in the range of any segment, and he can only jump to, if he's using this portal, he can only jump between Ai to Bi. Even if he's at Ri, he'll jump between Ai to Bi if he uses this portal. Is it okay? Okay, now some people are asking, can we solve this using recursive DP? Maybe, but again, I did maths in this. So,
hello.
Yes.
Where can you take one test case?
Yes. I'll show you that test case only, which is given in the input. So for the first test case, see, these are the values. So it's 6 to 17. These are Li and Ri, and you'll get teleported to 7 to 14. So basically, this is that. So Li is 6, Ri is 17, and if you start from anywhere, like if you use this portal at any of these places, you can jump to any place between Ai, that is 7, to Bi, which is 14. So this way, there are 3 portals, and these stars are the places at which you start. So now let's pick a position. Let's say you started at second, this 2. So this is the starting place, right? You can see my cursor, like zoom it. You are starting at this place, okay? Now, if you're starting at this place, you can jump. If you use this portal, you can jump anywhere from here to here. So let's pick, he jumped from this 2 to 8. So first of all, is it clear how we can jump from 2 to 8? Yes, no? Just tell me, is this thing clear to everyone that you can jump from 2 to 8?
Yes.
Okay. Now, if we are 8, can we jump to, using this portal, can we jump to 14?
Yes.
Okay. And first of all, someone asked, like, in using this initial portal, can we not jump directly to 12? No, we cannot, because we can only jump, if you are at this black line and you're using this portal, you can only jump at red line. Yes, you can start your jump from anywhere from L2 to R2, but you can only jump between L2 to A2 to B2. Now,
so can we consider a single line like with lower bound L and upper bound B?
Yes, we can do that, because yeah, you get it, but like I don't think this is clear to everyone. So let me go this like point by point. So basically, we can jump to 14. So this is the answer for 2. This is the 14. So this way we have to calculate for each query. Now, like someone already said, there is no point in going backwards. Like you will never jump from this position to here. Why? See, how is it beneficial for someone? Like this is, let's say this is 1 and you can jump from here to here. So if you're currently at this point, why will you jump here? Because you might be saying that, okay, I'll get a bigger portal. I'll get something like this. I'll get something like this. And if I jump here, I'll get another portal, which I can then take to jump here. But why if you're going back and then you're getting a portal which can take you forward, you can directly use that portal only and directly jump there, right? So it's never actually beneficial to go backwards. So is this clear to everyone? This is AI, AB, and these are LR. So is this clear to everyone? It's never optimal to go back. Okay. So now how I did this problem, see, for each portal, you just have to find, like for each segment, you just have to find, if you are at this point, see, I'm assuming that if I'm anywhere from here to here, I'll always come to this point first. That is, this is L, this is R, this is A, this is B. If I'm anywhere between L to B, I'll always come to first B, this position. And now from this position, I'll try to look at another portal, which is there. And for that portal, I'll pick the teleportation location, like let's say this, and I'll try to check, okay, what was the maximum distance? What is the answer? What is the farthest position that you can get if you were here? So answer for this will be same as answer for this point. Can you get it? Because you can always go from this place to this place. So answer, whatever answer you calculated for this place is the answer for this place. Otherwise, if you cannot go from, like if there is no continuous portal right now, see, for each segment, let's say this is one of the segments. First of all, if I'm anywhere between this to this, I'll always go to this point, right, B. And from this point, I'll always try to find if there is some other portal which is ongoing right now on which I can go. And what is the farthest B I can go. And for that B, whatever the answer was, that will be the same as, let's say this is A1, this is B1, this is L1, this is R1, this is L2, this is R2, this is A2, this is B2. So basically, I'm saying if you are at this point, you look down, there's another portal. Like apart from this portal, there's another portal. It is like it has this black line. Consider this as black line and this cross line as red line. So basically, you can use this portal if it is having a black line, black part at this range. So you can use that portal or segment to jump to B2. Now, once you can go to B2, the answer that was for B2, that was the farthest point for B2, is same as the answer that will be for B1, because you can reach from B1 to B2. Is this thing clear? So for each segment, I'll just have to pick up. So for each segment, I just have to pick up the farthest segment that can be reached by one operation. And for the answer for this segment, now this point, not segment, this point will be same as the answer that was for that point. Okay. Okay, so if black lines are not overlapping, let's say this was the case. This is the black line. Or maybe it was overlapping, but it was not under B1. So then also, you cannot go beyond this point. How will you go? Right? Yes. So now how will you, like for now, what do we have? We have for each segment, if we were at this point, what is the maximum farthest place we can go? Maximum place that we can reach. Is this thing clear to everyone? First of all. What about others? Okay. So now this is like, what do I have to answer? I'm not always standing here. Right? There are some random points that I have. So first of all, in order to answer these queries, what I can do, I can sort these queries in increasing order of their positions. And see, I have these black ranges already given to me, right? So what I'll do, let's say, suppose right now I'm here, I'll see, okay, is there any black range that is underneath this? If there is, I'll take it into consideration. And let's say once I reach here, I'll say that, okay, this range has already been completed. Like this, it has already been passed. So I'll remove it from my consideration. So by consideration, I mean that once I was over it, I'll take the places that I can teleport to into a maybe map or a multi-set. Why multi-set? Because it's possible that two or more segments are leading me to the maximum, same maximum B, right? So, and why use, okay, why use a multi-set or a set? So that I can get the farthest location easily. So first of all, you get this, like this is clear to everyone. Now I'll just explain this again. So for each point, sort it, like these are your queries. And then for this query, how we get the like ranges that are beneath these, first sort these ranges according to their L value. Then if the current, like if the range or segment that is having the lowest L value is before this star, before this current xi, then take its bi, the like the ai to bi, it would have been having some location where you can teleport it. So take this bi and insert it in your multi-set. Once you pass over this range, you pass over this segment, now you cannot anymore use this segment. So you can just remove this bi from your multi-set. So this way we'll calculate answer for each of these queries. Is it clear?
Why we removing bi?
See, why we are removing? Because now there is some range here maybe, but you cannot use this range because x is already like x is not able, like x, like from this point you can never go and use this. Like I already said, like there is no point in going backwards, right? So why will you ever come to bi?
मतलब bi अगर उस दूसरे x से बड़ा हुआ तो?
Like okay, it's okay, yeah, this is not possible that li, ri and ai bi, this is not possible. I explained this in the start only, right?
नहीं, जो bi है वो second query से बड़ा हो.
Okay, then you don't remove it. Then keep, like if this is the case that bi is somewhere here, then you don't remove it from multi-set. Use it. Find that if this is the maximum value that you can go to, then the answer for this is going to be the farthest that you can reach from this point. And those things we have already calculated for each bi, right? So the answer for this is going to be the farthest that you can go. This is the point. If this is the point, we have already calculated the value or the farthest location that we can get from this. Time complexity is n log n.
उसमें फर्स्ट और सेकंड क्वेरी का आंसर सेम हो जाएगा.
Yes. Okay, I'll show you, like I know this is very confusing, but I'll show you the code, and maybe if it gets clear, it's okay. Then otherwise I'll go back and explain you again. So first of all, I have taken n as input. Then this is a vector of array. So the first value is b, next value is a, then it is r, and then it is l. So I was given l, r, a, b in input, but I've taken those as b, a, r, and l. Why? Because I have to sort the segments according to their b values, right? Then I've taken an unordered map. So this is basically giving me what is the farthest position that I can reach if I start from a place. Okay. So this is basically, if I start from a position, what is the farthest position that I can go to? And this int will only have these b's. Like if I start from a segment i's bi position, then I'm sorting this VA. So this gets sorted according to the first value, that is this B. So these are another, like these are just for like implementation purposes. There are two multisets. The first one is farthest, that is what is the farthest position that I can reach, and this is the closing. If there is a segment that was currently going on, at which point it will get closed. That means the R value, not actually the R, but the B, because once you overcome, like you are in front of B, there is no point in going back, right? So now I'm calculating first thing, that is the answer for each bi. That is the farthest point that I can reach from the bi. So what I'm doing, first of all, while there is some segment that needs to be closed, and this is basically the position at which the segment was getting closed. So this is the rightmost segment that needs to be closed. If this is more than b, I'll close it. And one more thing, I'm going in reverse order. Like I'm going, see, like I said, explained you here, that we'll try to calculate answer. Where did I do that? So I explained you here, right? So this answer, this BI will take, if from this BI, this B1, from this B1, if this B2 is reachable, then answer of B1 is going to be the answer of B2. So if this is what we need, so we should have already calculated answer of B2, right? So that's why I'm going in this direction. So first I'll calculate the answer or the farthest point that I can reach from segments that are in rightmost order. So that is why I've sorted my VA in reverse order. So first, bigger values of B will appear. Then I'll see that, okay, if there is some segment closing, I'll close that segment, and I'll also remove that value from farthest. Then I'm for the current position. See, if I'm current position, I'm not using any segment. I can always be at that position only, right? So answer of B, that is the farthest that you can reach from B, is B initially. If the farthest has size, I'll pick answer of B as maximum of answer of farthest dot R begin. This means what is the maximum, what is the farthest that you can reach from this point. Then since the current segment is now opened, now you can insert this in your closing also and farthest also. Now, in order to answer the queries, first take X as input. Then since we I'm going to sort these X values according to their positions, I need to make sure that the final order doesn't get affected, right? Because I have to answer those queries in order. So I'm making another query vector, which will have the first value as the xi and the second value as the indices. Then I'm sorting these second query vector, that is, it will get sorted according to these X values. Now, these are the final answer for each of the queries, and I'm taking vector array int 4 for VA2. So this is basically, initially my value was BALR, right? Now it was BARL. So now in this vector, the values are in order of LRABY, because I need the values or the segments sorted according to these L values. That is the point at which the segment starts. So I insert these in VA2, I sort them in reverse order again, and now I'm clearing these two multisets. And for each of my queries, let's say this is now the queries will appear in order of X, like the X value, XI, right? So now this is the index and this is the position. So while there is any segment that is currently going on, I'll pick up the position if it has already been closed. That is, if it has already been passed. So I'll clear it from my farthest. I'll close that segment. Now, if some segment is going, like if no new segment has opened up, I'll use that segment also. Just need to check that, okay, there's also a possibility that a new segment opened and closed before this X. So I'll just remove it from my VA2. Otherwise, I'll insert that segment's B values in my closing and farthest so that I can use them further. Now, like I said, the answer that for the current query will always be more than or equals to E. So right now it's E. And finally, if the farthest has some size, I'll insert this, like I'll update my values at this index. That is the answer for this index query as this thing, and answer for the farthest that I can reach from here. So can I go back to the, I'll give you now a simpler, again, once more, the idea, what happened here. So after seeing the logic, you know the flow, right? So, okay, what happened? First of all, we calculated for each range. So basically, if this is the segment, that is L to R, you can go to between A to B. For each B, we calculate what is the maximum that you can reach from this B. And then once you have that information, you suppose these are the points or the query starting points, you'll sort these. And from this, you'll try to see which all segments are open. And from that, you'll pick up the segment which is giving you the maximum B. And for that value, you'll say that, okay, you have already calculated what is the farthest point that you can reach for each B, right? So this is the value. The answer for this B is the answer for this segment. So this is what's being done. So that was the implementation, and this is the general idea.
What if that point is not covered in any segment?
So in that case, nothing was open, right? So if nothing is open, I am already saying that the answer for any segment is also that point also. Like I'm doing it, I'll show you the implementation once again. So like, see, while I'm answering queries, I'm always making sure that the vals for this index is also E. In case there are some further points available to me, then I'll take the maximum value, right?
Yes.
So in case like there are nothing, like no things open after this point, I'll make sure that the answer is at least this value, that is the current starting point, and from that position I'll try to take the biggest value.
So effectively, like we are doing, like for each B, the value of B, we are calculating what is the farthest point we can reach, right?
Yes, from that point.
From that point, like what is the format of the queries? Like the queries which are given, we have been given the starting points, right?
Yes, the starting point where Andre is going to start.
Okay, and from that we are supposed to tell that what is the farthest distance we can go.
Yes, exactly. So
first, what is the first step we'll decide? Like if we have been given a point, then we'll see under which
what is the segment that you can use right now, what are all the segments, and out of those segments, what is the maximum rightwards position that you can achieve.
Okay, so our first step will be to select the segment, which the first segment we can use, and from that segment we would have already calculated what is the farthest distance we'll calculate.
Yes, exactly.
We can move, right?
Yes.
Can you please show go through the code again, because like when you were showing the code, I couldn't get the logic earlier.
Like I think this could have been done like way more simpler. So like I'll maybe update this after the session, and I'll upload that updated code, which is easier to understand.
And can you please explain this part, like the auto BAR, like what are we doing here?
This is B value, this is A, this is R, and this is L.
Okay, R and L is the right and left point of
the place that you can start your jump from, and A and B are the left and right part where you'll end.
These are the red lines, like B and A are the red lines.
These are the red lines, and L and R are the black lines.
Okay. And what is about this syntax? Like I'm new to this syntax. Like I have seen like auto A.
This is like this is a really ugly syntax. Like I said, I didn't give
just
that much
syntax in the for loop. Like auto.
Yeah,
like,
we should usually use a vector of vectors, or maybe like have different arrays, B array different, A array different, R array different, and L array different. So sometimes it's better to have those things.
Like
because like I also myself, like I had to write this thing, because once I start from here, I won't know what is B, what is A, what is R, what is L, right here. So this gets really confusing if you're doing it like this.
So, like
but
what
anyway,
is this array actually doing? Like B, A, R, and L. Like
yes, these are the values. You have to take the input, right? Somehow.
Yeah.
So either you can make 4 different arrays, or you can make a 2D array or a 2D vector, right?
Okay. So effectively, like you are doing making a 2D vector.
Yes.
Okay, for inputting the values. Okay.
Yes.
And this is how we are iterating. Like we are using to iterate over a 2D vector. We are using auto. This is the syntax we should use, like, right?
No, auto. No. This is not like only for this. Auto is for everything, and it is not required that you should do it. Like you can do this normally also.
Right. I mean, like if we have to do with auto. Okay.
Like if you have to do it with auto, you can do it like this, and you can do this also according to like the way we do VA dot size.
Right.
This also would work.
Right. So the input part is done. Okay, fine. Like after the input, what are we supposed to do?
We are calculating what is the farthest point from each B that we can go.
Okay, from each B, what is the farthest point we can go? So how do we calculate it?
Just see that if there is some closing, and if there is some closing, close that thing. Otherwise, take like the current B will always be one of the positions, like one of the possibilities that this is the farthest that you can go, right? If otherwise, what?
I think someone else is asking something.
Excuse me, sir.
Yes, yes, yes.
So I'm asking that you are saying that from each B, we are finding out the farthest point where we can go, right?
Yes, yes, yes.
So, sir, but for each interval, their B is only the farthest point that we can go in that interval, right?
But you can use another interval also, right? After using this interval, you use some other interval, and then again you can go further. So you can chain.
Okay, if suppose one interval B is overlapping with other interval, if it come greater than L of other interval, then we can go till B of that further interval, right?
Yes.
Okay, thank you.
So like we to find the farthest distance, we are actually doing that if a black interval is on, like if our red, the B is inside a black interval, right?
Yes.
So we choose the left area, like left, like what is the, where is the comparison? Can you comment where you have done that in the which particular line? Like where we are finding the farthest distance for B,
Yes,
a particular B. Because sometimes it's hard to understand in the code. Okay, this is the where, okay, maximum of answer of B. Okay, one is like the current B, or what is the farthest dot R begin doing?
It is picking up the farthest that you can go from that place, and what was the answer at that place? What was the farthest from that place? You see.
So like how did we calculate the farthest array?
We had already calculated it earlier, right? That's why I'm going from right to left.
Okay, so we have already calculated the farthest point array. Like that's what I was asking. Like, how did we calculate the farthest point array?
So
couldn't understand
like
the
this is
syntax.
how DP works, right? From one value you try to get other value. So this was already calculated earlier, and now we are calculating this. Now it will be used after, like maybe after some of iterations. So the values that we are already calculating, we are using those values only.
Okay, okay.
This is how DP works.
Right, right. Okay, I'm getting it. What you're doing. Okay. Okay. Thank you.
Okay, okay, okay. So that's it for today. So
yeah.
Yes.
Can we discuss E problem?
No, I won't be discussing E problem.
Okay. Like it's a simple like DP.
Okay, just okay. You can raise a query and tag me it if you want me to. So I'm
One more thing.
right now. Just give me a second.